Okay, we will continue to have the presentation of Team 2 on the solutions of the problems in Chapter 5 after his PBL report in 15 minutes.
So, hi everyone, my name is Don Kim and I'm in Team 2, and today I will going to present about my PBL report, and then my team members will introduce to you about our team project. So I stated lots of definitions and concepts about our discrete mathematics, but you guys will know better than me, so I will skip this part because everyone has all the concepts right. And 좀 넘겨야 될 것 같은데. And so this is the Q&A part, and somebody unwrote the question in the Q&A section, and I answered at the 10 questions. And most of all, I was impressed in where is it? 없어졌네. So yeah, among that, let's remind when we are before the midterm exam. Someone asked that whether when we check whether it is prime number or not, someone asked why we have to check only the prime numbers, not all the numbers. So I answered it in Korean, but some foreign students said to me he cannot understand the Korean, so I translated, and other classmates are translated and add some as some concepts. So I very appreciate it, and it was very meaningful to me because this class is different than other class because the other class are only studied by oneself, but this class are discussion and communicate with other classmates. So I was very impressed. So this question was so impressed to me. And I was very thankful to all of our classmates because I can get lots of, I feel so great because other students are studying so hard and they did lots of questions and the answers and concepts and discussions in our Q&A section. So yeah, I did very hard too. So yeah. I think it is great. And yeah, so I answered that tautology is truth, and the professor answered to me, and it was also impressed because the professor make an answer and the solution to me very quickly, so it was also impressed. Yeah, and this is all of my Q&A part, and also of the finalized questions. And yeah, I think this is the end of my PBL report. And since discrete math, I think at the first time, I think this class is only about the mathematics. But when I come in class and hear the class, I realized that this class is close to my major software. So I was very interesting while we were running the trees and the graphs and other codes, the sorting algorithms, because I run at the data structure class before semester, but it is very similar to me and it is very close to my major. So I was very interested in this class. So I was very happy to get this class in this semester. So I think this is the end of my PBL report, and my classmate will announce a final comment. Oh. 저 파이널 코멘트 부분이 사라진 것 같은데요. 같이 업로드했었는데? 네, 제일 뒤에 고맙습니다. So the final class, the first month of the first of my PBL report, I think I was very nervous because it is very different than I expected. So I did a small of the Q&A section, but the midterm PBL report, my question and my answers are going better and better than the first PBL report, and it is very similar. In this part, it is very similar because we learned about the sorting algorithms and other algorithms. So it was very familiar to me, and so I did more and more than the first month. And the third month, I did lots of then midterm PBL report. So, and we started the team project in this month. And the final month, we did lots of things, and I was very thankful to myself and my team, and also my classmate, because everyone helped me to study this class very hard and very well. So I think this Christmas will help to me. Not only this class but also my major can help to me. So I think it is, good, and everyone was great.
And the last page of self-evaluation. Q&A 몇 번 했는지 페이지. Last page of self-evaluation. You have 149 pages. How many times?
Yeah, I did 103. Yeah.
What was the most interesting thing that you
Yeah, I was mentioned that the one classmate asked me whether when we check the prime.
Good. Then you can continue your solution. 질문을 다시 한번 소개해드려요.
And our team leader, Kim Eun-min, will introduce to you guys about our team project.
All right, so our team project is on Chapter 5. We're assigned with Chapter 5. So before I go over some questions, I would like to simply go over Chapter 5 as a simple review. So in order for everyone to understand the questions better. I'm sorry. Okay, so first we learned about divisor, what a divisor is. So basically what a divisor is based on its definition 1.1 here, it shows that a divisor is a factor of any number. When you divide a number, the number that divides is the divisor. So some things that we learned about are what are prime numbers, and here's a simple algorithm that we learned about to see if a number is a prime number or not. And we also learned about the fundamental theorem of arithmetic. This basically says that any integer greater than 1 can be written as a product of prime numbers being divisible by itself and 1. And if the primes are written in decreasing order, the factorization is unique, and you can see here how it can be solved. And we also learned about GCD. GCD is the greatest common divisor. So between two numbers, it finds the highest possible divisor, and that's basically what the GCD is. And we also learned about the LCM, which is kind of the opposite. It's the least common multiple, and it's the smallest positive common multiple of m and n. And we also learned about binary, octal, decimal, and hexadecimal number systems. Binary is 2 symbols, octal is 8, decimal is 10, hexadecimal is 16. And so we learned how to add them and switch from binary to decimal, decimal to hexadecimal, and so on. And we also learned about the Euclidean algorithm, and maybe this might be the most important thing on chapter 5. It's an algorithm for finding the greatest common divisor of 2 integers. So like I said about in 5.1, the GCD, this is basically more information about it and how to solve them. So some questions or some problems from the chapter. So the first question is tracing an algorithm about input and try to see if it's a prime number or not. And so here we see the tracing of the numbers. And every time you divide it, if it equals itself and not another divisor, then it must be prime, because a prime number is only divisible by 1 and itself. And here. Next question, chapter 5, question 33. This one is also checking if it's a prime number or not. And this way, instead of using an algorithm, we solve it by hand. And so this one, so every prime number, 1, 2, 3, 5, 7, 11, 13, so on and so forth, we keep seeing until it equals not a prime number. And so we try 2 and 3, and then it doesn't work. We try 2, 3, 5, doesn't work. 2 times 3 times 5 times 7, still doesn't work. 2, 3, 5, 7, 11, doesn't work. And all the way to 13 we tried, and here is not a prime. So this is the final number, because it can be divided by 59 and 504.
How could you check that number is not a prime
No.
3, How could you check that is not a prime number? Is a prime number?
No, we can. Oh, we check through an algorithm or a program, and so we just put in the number, and then.
You should have a reasoning there.
Okay.
How you check it.
Okay. Yeah, but we ran it through a program, and then if it says prime or not, we just. Yeah.
We have learned this, so you may give self-addressed or code that we can check
Okay.
whether the given number is a prime or not. Okay.
And next question is about A or B, and B and C, and A and C. And this is just a proof that we learned that's based on a theorem we learned about above. And so we first find about this, A and B, what it equals, and then what B and C equals. And basically it's the same thing as from from here to here. So it says that A and C are also.
저걸 구분하지 않으니까 Bn이 B 속의 n인지 B 곱하기 n인지 전혀 구분이 안 되잖아. 그러니까 저게 you should follow the way of writing mathematical symbols. You don't know. It's hard to figure out what the meaning of Bn. That could be a product of 2 integers, or that could be a B sub n, the sub-index.
Yeah.
It could be many things. If you don't write it in a proper way, we don't understand. And computer cannot understand. So you cannot use those, you cannot get help from those tools that you can use it. So
Oh, yeah.
writing mathematical symbols in a mathematical way is the things that you have to learn from these courses.
All right. So next.
So your point was deduct.
Oh. And so next one is, this one is based on bit numbers, representing bit numbers. And so for a bit number it's composed of 2 numbers, 0 and 1. And so we want to see the number 127 into a bit number, binary number. And so here's the process. So we since binary is up to 2, we just keep dividing by 2. And if the percentage of the number divided by 2 is 1, then we put a 1. If it's 0, then we put a 0. And we just keep adding it up eventually from right to left in order. And so in this case, they all happen to be 1. So we just keep writing 1, 1, 1. This one comes from here, and so on, so forth. And so 7 bits represents the number, decimal number 127. And next. Okay, so this algorithm is actually based on the Euclid algorithm that we learned about. It's pretty simple. So the Euclidean algorithm is basically the greatest common denominator algorithm. So here, if A is less than B, then we can swap them. And we keep going until we find basically the GCD in this algorithm. This one's pretty straightforward. This was actually we learned in class. So next, this is also one we learned in class, test whether an integer is prime. And this one part makes it a little bit simpler because we only go from 2 to square root of n, n being the number we get from here. So instead of going through every single one, we only need to go through square root of n, so the time complexity is actually better than the one before. Should I keep going?
That problem was on the midterm examination, and I will make about 2-3 problems in your final exam from the midterm examination. Yeah. So from the midterm examination, I will choose 2-3 problems so we can double check in the final exam.
Okay, next I'll go over our project that we did. So our project idea is recursive and non-recursive programs in Python to compute the greatest common divisor. So this also goes, since the main idea of this chapter was, I think, or we thought was based on the Euclidean algorithm, we wanted to find 2 ways to do it and to find the time complexity of both programs to see which one is more effective and better. So reasons, like I said before, find the GCD of 2 numbers are the most important things we learned about in this chapter. Sections 5.1 and 5.3 cover this subject in detail, and we think it is vital. And it also pertains to Chapter 4 because Chapter 4 is based on algorithms, and we thought it'd be cool to include more than one chapter into our project. So here's how we try to do it. First, find all possible positive divisors of each number, and then compare the highest, and keep comparing until we get the highest overall, and then we can print out that final value. So first, the non-recursive way, we must use iteration. We assume that we will only giving 2 values to compare, so we're only taking 2 values to find the GCD. And since it's iteration, we have to use a for or while loop, and then we need to find the smallest value, and we loop until 1, until the smallest value, because there's no reason to do all of the values to the highest number, because the GCD comes from both numbers. We keep reiterating until it equals 0, and then the most recent GCD value we will just print out. So it's a pretty simple program. So if x is bigger than y, we want the smaller int to y, and else smaller int to x. So we, like I said before, we want to iterate the smallest number because there's no point in going to the bigger number. It just makes the time complexity higher. And so for the range of the smallest number and L, we keep going until both GCDs are, both divisors are division, and the remainder is 0. Then we know that it's a divisor. And if it is a divisor, we check it to GCD. And so, for example, we had A equal to 100 and B equals to 55. And we tested our program, and we got 5, which is the correct answer between these 2 numbers. And
you better have the text here instead of image. 그러니까 여러분들 저기 MIT에서 진짜 코딩 관련된 것들 이거 숙제 내시면 채점할 때 조교들이 어떻게 채점하는지 알아요? 코드 보면 그 분량도 파일 분량도 그리고 기본적으로 텍스트 분량 보면 그 평가 복사했는지 안 했는지 대충. 근데 이미지 이렇게 쓰면 이거 비교가 안 되죠. 파일에다가. 되게 남의 거 카피해서 쓰면 조금 뭐 편집해서 뭐 한다 그래도 거의 흉내내서 이렇게 바꿔서 설명 좀 달고 뭐 한다 그래도 기본 코드들 거의 남의 복사한 거는 그대로 하나도 못 건드리잖아. 그렇기 때문에 그 바이트 숫자에서 거의 차이가 안 나. 그러니까 그런 것도 보고 표절, plagiarism can be checked. But if you use the image like this, it's hard to check for plagiarism. So it's not recommended. Also, we sometimes we need to double check whether your algorithms are working properly. Then the TA should check, should learn your code. But if you don't supply it, then they have to type it. Usually TAs don't give a good credit on those. They do not want to waste their time to retype what you did to give a better grade. So it's not fun to just show it and insist you got the right answer. They will like the full credit of it.
All right. So next is the recursion way. Since we're not using iteration, we must loop by calling the function itself. And same cases, we're assuming we get two values, and so we keep going until the first value is equal to 0. In that case, we're done, and we return the second value. And so we keep going with x percentage y, and percentage gives the remainder. So we keep going, and it's a pretty simple code. This is what was written in the files I see in the Sage code, but we converted it into Python. So if it's y equals 0, we return this value, and else we return this same function, but we switch the values, or we're not switch, we set x equal to y, and y equals to x divisor y. And then we assign the values, similar before, and get the same value. So, but we don't have the real code. It's on my laptop, but. Yeah. Okay, so time complexity of non-recursive is O of n, and time complexity of recursion is log O of n. So obviously the recursion has a better time complexity. It's log n is a lower number of n for almost every value of n. And so final thoughts. So we thought this project was fun because most of our majors are related to software or computer science, and we knew both ways effectively. And after final PBL, so first month we thought that the class was fun. Or at first we learned about many things, and I'm pretty sure most of us weren't very confident about the Q&A at this point. But once the midterm hit, we realized how important the Q&A was, and we also learned more things related to our major and the Euclidean algorithm that we talked about today. And third and final month, we got our team members and we worked on the project together, and it was a fun time because I think we almost mastered chapter 5 because we had to go over many times to solve the problems and write the project. And this is just extra feeling.
Okay, good. Any questions or comments? 자, 다음 팀. Any questions or comments?